Hello, today we are going to learn about the triangle congruence conjectures. But before we do that, let's look back at what congruence means and congruence with triangles. So if I have triangle RUF is congruent to triangle DOG, what side is congruent to DG? D and G is the first and last. Hopefully you are saying side RF. Similarly, what side would be congruent with UF? That's the last two letters. So hopefully you're saying the last two letters here, O and G. Now if we look at angles, what angle is congruent with O? Hopefully you know that's angle U. And what's congruent to angle GDO? GDO. That'd be FRU. Angle FRU. So if you want to state every congruence in this diagram, we know TB is going to be congruent to EL. BA is going to be congruent to LF. And then the first and last, TA and EF. Now angle T and angle E would be congruent. B and L. And F and A. So we know that there are 6 things that are congruent in one triangle with the other if we have this one statement. So there's a big question. Do we need all 6 of these things to prove that those are congruent? How do we know when two triangles are congruent? What if just one thing was congruent? If this side, do these triangles have to be congruent? For instance, could I move this side to look like this? And hopefully you see that those are not congruent. Or this angle, if I have one angle, does it always have to be the same triangle? Hopefully you see the smaller angle as definitely not as big, the same size as the big triangle. So one piece of information is not enough. Never proves congruence. The second thing, what if there's 2 pieces of information? What if there's 2 sides? Do these have to be congruent? Now I think the answer to this is if I took 5 there instead of moving 4 here, if I moved it up here, would that make the congruent triangle? And hopefully the answer is no. This triangle is much different than the big triangle. 2 congruent angles? You could have angles, but just make the triangle smaller. And this could still be 45 and 75, like so. So this one is another no. So we have no, no, and if we have a side and an angle, we could easily take this side, oops, and draw a line like this. And this small triangle has the same dimensions as this big triangle if we have a side and an angle. So hopefully with 2 sides, or 2 pieces of information, we know that never proves congruency. What about 3 things? Now if I have 3 sides, 5, 4, and 7, this has to be 5, that has to be 4, and that has to be 7. Is there any way we can move these sides and make a triangle that's different from this one? Well, if we did, it would somehow be able to flip back on this. So this one, if you have all 3 sides congruent, this would prove congruence. There's no way that you can connect them in any other way except the way that we have them here. Now if we have 5, 75, and 4, 2 sides and the angle in between, this one, if I kept this angle and this side in place, there's no other way I can draw this triangle other than connecting this line. So this one would also prove congruence. So it's looking pretty good for 3 things, except when we get 3 angles. This is just like 2 angles. we could draw this smaller, where you have 45, 75, and 60. So in this case, this would not prove congruence. So 3 pieces of information sometimes prove congruence. And we'll go over which ways work and which ways don't. All right, here we go. Now if we have 4 pieces of information congruent, then no matter how we cut it, say maybe this one, there's always that side angle side or something. There's always going to be some way to prove congruence. So 4 pieces always prove congruence. And now we're going to go into more specifically. So if we have 4 or 5 pieces of information, or 6 pieces of information, we know it's congruent. It's just 3 where it's a little weird. So if we have these 3 matching up with these 3, we already said if we have side, 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 those have to be congruent. There's no other way that we can line them up and have a different triangle. And this is what you need to have in your paper. You need to know that this side, 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 and we just abbreviate by SSS. And that's if 3 sides in one triangle correspond to 3 sides in another. So if I take these 2 triangles, saying that this side corresponds with this one, this side corresponds with that, and this side corresponds with that, just from that piece of information, we know that those 2 triangles have to be congruent by SSS. Now, if we have 2 sides and the angle in between, does this line have to be drawn here? Is there any way we can draw it, keeping these 3 elements the same? The answer is no. There's no other way you can draw it, so this has to prove congruence. And we call this side angle side, where we have 2 sides and the angle between them in one triangle is congruent to the 2 sides and the angle between them in the other. And we'll draw a picture to show that. So we'll have maybe 8, 30, and 5, 8, 30, and 5. Since you have that, those 2 triangles have to be congruent. I might not have drawn that perfectly, but hopefully you can see that if we have side and the angle in between them and the side, we know that those are congruent. Now this one, we have one side and the 2 angles. So once I have the side down, I continue out in this direction, continue out in that direction, and they have to hit at that point. There's no way we could form a different triangle with those 3 pieces. So we call this ASA, because we have 2 sides and 2 angles and the side in between them. So in this situation, we'll draw it here, we'll draw it here, and we'll have this angle match up with this angle, the side in between them, and this other side, or this other angle. So this is what we call angle, side, angle. Now, if we have 2 angles and the side isn't between, so if I have this as 5, this goes up at 75, this goes back at 85, and again, there's no other way you can draw this triangle other than what we have drawn here. So this is side, angle, angle. So that's if 2 angles and a side that is not between them in one triangle are congruent to 2 angles and one side that's not between them in another, then those triangles have to be congruent. What we want you to draw is showing that we have 2 sides, or 2 angles, and a side that's not between them. So side angle angle or angle angle side has to be one of these 2. So let's take that one. So these 2 would have to be congruent triangles, because you have 2 angles and the side not between them. So there's 2 conjectures with 3 letters that don't work, and that's angle, angle, angle. We talked about that earlier, and side, side angle. Now the reason why side, side angle doesn't work is if I draw these angles like this, and I knew that this side was 30 degrees, I could draw a third piece of a triangle here and say this is 6 and this side is 8. Now I could take the same measurement, instead of it being out here, I can move it over here and have this equal to 6. And so I have two triangles, 38 and 6, 38 and 6, and they have the same dimensions. So we know that there's two triangles you can create with an SSA situation sometimes. And so that does not prove congruence. All right. However, there's one time when SSA does work. The angle has to be 90. So if I know that this is a 90-degree angle, by Pythagorean theorem, I could figure out this side being equal to this side, because the Pythagorean theorem would be the same in both triangles, so then it would actually be side, side, side. But since we just know these two sides and the right angle, we call this hypotenuse leg. If the hypotenuse and leg of one right triangle are equal to the hypotenuse and leg in the other, so let's say this is 8 and 6, this is 8 and 6. If we know that, these two triangles have to be congruent by HL, hypotenuse leg. And remember, the hypotenuse is always the longest side in a right triangle. It's across from the 90 degrees. The leg is one of the other two sides. All right. Now, I hope now there'll be another video of going through specific examples.